Welcome to Maths and Science by IITian channel. In this lecture, I will be taking up a very important topic in number theory, where we will be finding a minimum value of a plus b plus c plus d when a to the power of n minus b to the power of n minus c to the power of n plus d to the power of n is divisible by 2023 and the value of this is greater than 0, such that a, b, c, d are distinct integers greater than 0 and for all values of n greater than or equal to 1. This is a very good example involving Newton's sums and also advanced topic in number theory. Please pay attention to it. It's a very good practice question for understanding many important concepts in number theory, including Newton's sums and also congruence modulo, modular arithmetic, and also to find the Newton's, to understand the Newton's identities or Newton's sums and what it means. Let's move further. Question is, find a plus b plus c plus d minimum value of when a to the power of n minus b to the power of n minus c to the power of n plus d to the power of n greater than 0 is divisible by 2023 and ABCD are such that they are distinct greater than 0, that means positive integer values, and this is valid for all n greater than or equal to 1. Solution. Here what it is given, it's a very good question. Please try to understand what it is given here. 2023 divides a to the power of n minus b to the power of n minus c to the power of n plus d to the power of n greater than 0. This implies, when you write in the congruence modulo form, a to the power of n minus b to the power of n minus c to the power of n plus d to the power of n is equivalent to 0, because this is divisible by 2023, hence remainder will be 0. 0 mod 2023. This can also be written as, you take out negative values on the right hand side, it will become a to the power of n plus d to the power of n is equivalent to b to the power of n plus c to the power of n mod 2023. This is the very important step in this solution. Now, from the Newton's sum, power sums, these power sums are already explained in my previous lectures on number theory. Please refer to them. When a to the power of n plus d to the power of n is equivalent to b to the power of n plus c to the power of n mod 2023. It is a very important concept we are developing here. This implies two possibilities, either A equivalent B. You see, A equivalent B. And D equivalent C. Or second possibility is A equivalent C and D equivalent B. This is mod 2023. This mod will not go. That is A equivalent B, A equivalent C in the second option, D equivalent B, mod 2023. This is also important concept which you should understand. First concept is sum of the powers a to the power of n plus d to the power of n equivalent b to the power of n plus c to the power of n mod 2023, and that particular equation in powers, congruence modulo equation in powers, has given rise to a two possibilities. One is A equivalent B and D equivalent C mod 2023, and second is A equivalent C and D equivalent B 2023. Now, when A equivalent C and D equivalent B mod 2023 is considered, this implies A equivalent C mod 2023 and D equivalent B mod 2023 implies, what is that? When A is divided by 2023, there will be a remainder C. When D is divided by 2023, there will be a remainder B. So that A can be written as remainder C plus 2023 into some factor K1. D is equal to B plus 2023 in some factor K2. Here what we wanted is that ABCD to be distinct and positive. That is our condition. Hence, what we wanted? We wanted a sum a plus b plus c plus d to be minimized. We have to minimize the value of this sum. What is the sum value? S is equal to A is C plus 2023 K1 plus B plus C plus D. D value, let us do this. B plus 2023 K2. That implies the total sum what is to be minimized will be 2C plus 2B plus 2023 is common, K1 plus K2. Here ABC, given that A, B, C, D are greater than 0 and are distinct. And S to be minimized. S is equal to 2B plus 2C plus 2023 into K1 plus K2. When 2023 is multiplied by some K1 plus K2, here you see, you please try to understand how we minimize. A is equal to C plus 2023 K1 and D is equal to B plus 2023 K2. Now, what best the minimum value? A, B, C, D are integers greater than 0, positive integers. What can be the minimum value that either A or C or B or D can have? Minimum value of A, B, C, D greater than 0 can be either A or B or C or D should be equal to 1. That is the minimum value. We will see whether we get the other conditions satisfied or not. Let's apply either A or B or C or D is equal to 1. A should be greater than 0. That implies K1 should be greater than 0. K1 cannot be negative. If K1 is negative, what happens? If C is minimum, if C is equal to minimum, then a to be greater than 0, k1 should be greater than 0. It cannot be, k1 cannot be negative if c is minimum. Similarly, b is equal to minimum, then d to be greater than 0, k2 should be greater than 0. That means k1, k2 both are to be greater than 0, a, b, c, d to be greater than 0. In the equations, a is equal to c plus 2023 into k1 and d is equal to b plus 2023 into k2. These two conditions, they give rise to a condition where, because all are integers, we treated them as Diophantine equation. All are positive integers. When everything is a positive integer, it is a positive integer, k1. C is a positive integer. A is a positive integer. Similar the case with the same. These conditions give rise to possibilities that 1, here it is 2023. Either C or B to be 1. That is the least possible minimum value. When something multiplied by 2023 and added to some other value, then k1 should be, for minimization, please try to understand this. k1 should be equal to, k2 should be equal to 1. If k1, k2 are greater than 1, then a value and d value will be higher. For minimization, we are using the logic. Now, what we consider here, let c is equal to 1, k1, k2 is equal to 1. It is the case of minimization we are talking about. A is equal to c plus 2023 into k1, that is equal to c is 1 plus 2023 into 1, that is equal to 2024. A, B, C, D to be distinct. A, B, C, D are distinct. Once we have taken C as 1, what will be the minimum value that is left over in case of B? The leftover value after 1, the minimum value for B will be 2. But the minimum value of 2023 into K2 can be 1. There is no restriction for K2 to be minimum. Then it will be 2025. That means A is equal to 2024. A is equal to 2024. B is equal to 2 and C is equal to 1 and D is equal to 2025. These are the minimum values what we have got from the conditions with the logic applied. Then the minimum a plus b plus c plus d will be 2024 plus 2 plus 1 plus 2025. That is equal to 4049 plus 3 4052. The answer is 2023 when it divides a to the power of n minus b to the power of n minus c to the power of n plus d to the power of n greater than 0. The minimum value of a plus b plus c plus d is equal to 4052 when a, b, c, d are greater than 0, n is greater than or equal to 1 and a, b, c, d are distinct. The answer is 4052. This is how we have to approach a problem. Here what we have done, congruence modulo equation has given the value as a to the power of n plus d to the power of n equivalent b to the power of n plus c to the power of n mod 2023. When that condition is there, then it gives rise to two possibilities. Either a is equal to b, that means a equivalent to b and d equivalent to c, so that congruences to be compatible mod 2023, or a equivalent to c and d equivalent to b mod 2023, so that they are compatible. Now from that we got the equations and we got the total a plus b plus c plus d value, and we wanted to minimize them, and these are the conditions which we have applied carefully, so that we got the minimum values for a, b, c, d, which is found to be 4052. The sum of a plus b plus c plus d is equal to 4052. This is how we have got it, and the Newton's sum principle is applied here. Congruence modulo equations are applied here, and also the logic of algebra to find the minimum value is applied here, and so that we got the answer with all these applications of number theory and algebra coupled together. We got the answer as 4052. With this, I want to conclude this lecture, and it gives a lot of insights about the number theory, congruence modulo equations, Newton's sums, and also how to arrive at the minimum value algebraically. Use these concepts whenever you come across this type of questions or other type of questions where these principles can be applied. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture. If you feel there is a value addition because of this lecture to you, kindly hype this lecture, kindly share this lecture and my channel details, and kindly subscribe to my channel Maths and Science by IITian. I will be releasing this type of typical questions regularly in this channel, and try to understand the concepts and use them. Best of luck to everybody. Thank you for listening to me.